You know that feeling? You're just drowning in information, but what you really need are those few key insights. That's why we're here. Welcome to the deep dive. We take all that material you send us and, well, we boil it down to the essentials. Think of it as your fast track to getting properly informed.
And today, we're tackling something really interesting in AI, Retrieval-Augmented Generation, RAG for short.
Exactly. So one of our listeners, the learner, sent over some great stuff, excerpts from an ebook called RAG by Rajamanikam and Tanamuthu. Now, the learner, they want knowledge that, actually sticks.
Yeah.
Real aha moments.
Yeah.
And definitely not getting bogged down in the weeds. Sound familiar?
It does, and that's our goal for this deep dive. We're going to unpack what RAG actually is, why it's a big deal, where you might see it, how it works, how you build these things, the challenges, and what's coming next.
Yeah, just imagine AI's language skills, but hooked up to this, endless library of current information.
Powerful stuff.
Okay, so let's get into it. What is Retrieval-Augmented Generation?
Okay, so our RAG, at its core, it's a really smart mix of two different AI approaches. Think of it like bringing two kinds of experts together. First, you've got retrieval systems. They're brilliant at finding specific info in huge data sets, like super librarians, but they can't usually write a nice flowing explanation about what they found.
Right, they find the facts, but they can't really chat about them.
Exactly. Then, on the other side, you have your generative models, the LLMs everyone talks about. They're fantastic at creating text that sounds human, but their knowledge is sort of frozen based on whenever they were trained, no live updates.
So RE is like pairing that librarian with a really good writer. Is that a fair way to put it?
That's a great analogy, actually. It really does bring the best of both worlds together. Our RAG uses that retrieval part to grab the most relevant bits of info from, say, a database or a set of documents, and then it gives that info to the generative model to write a response that's coherent and grounded in those facts.
The ebook actually describes it as using LLMs to talk with our own data. So instead of just keyword searching PDFs, you could ask a normal question, and RE finds the right paragraphs for the LLM to use. That seems like a big step up.
It really is. And it solves a big practical problem with LLMs too, that limited input window, right? You can't just feed them a whole book. RE acts like a smart filter. It picks out only the most relevant pieces for the question, giving the LLM the context it needs without, overwhelming it. It's a neat architectural solution.
Okay, smart combo. But why does it matter? What real problems does RE actually solve?
The biggest thing right off the bat is getting more accurate, more reliable answers. Because RE can pull in real time or at least very recent information, it avoids that classic AI problem of giving you outdated or just plain wrong info. Super important in fields that change: fast news, science, tech, you name it. So for the learner, it means answers you can actually trust more.
That's huge. Feels like everything changes daily sometimes.
And it's not just about being up to date, it also massively improves how well the AI understands the context of your question. By fetching relevant documents, it gives the model a much richer picture, so the answers are more on point, more aligned with what you actually need. It lets the AI get the nuance,
Right.
Beyond just matching keywords. That's a real leap towards better comprehension.
The source material really stresses this for areas like medicine, law, finance, engineering too. Places where being precise isn't just nice, it's critical.
Absolutely critical. Think about a lawyer using an AI assistant. With RAG, it could instantly pull up the most relevant current case law, or a doctor getting the latest research findings on a specific condition right there and then. The accuracy boost is enormous. And because it can dynamically pull new info, it adapts to the real world in a way static models just can't.
And here's something that jumped out at me. The ebook says RAG helps cut down on AI hallucinations, and the AI just confidently makes things up. So moving from AI that might sound convincing but be totally wrong to AI that's actually based on retrieved facts, that builds a lot more trust.
Exactly. By grounding the response in actual data it just looked up, RAG makes it much less likely that AI will go off the rails. That increased trustworthiness is a massive advantage. And obviously that's huge for businesses, using it for customer support, internal knowledge bases, anywhere you need reliable help.
So it's not just tech for tech's sake. It's fixing some fundamental AI reliability issue.
Okay, so where are we actually seeing RAG being used now? Any concrete examples?
Oh, the applications are spreading really fast. Customer support and chatbots are a big one. RAG-powered bots can access a company's entire knowledge base, FAQs, manuals, whatever, to give quick, accurate answers. Cuts down wait times, makes customers happier, automates the simple stuff so human agents can handle the tricky problems.
Yeah, the book mentioned a telecom chatbot troubleshooting internet issues using specific steps from their own support docs. Much better than those generic bots we all hate. Totally. Then there's legal work. document analysis, compliance. Aura can quickly find and summarize relevant legal precedents, help lawyers with research, make sure businesses are following the latest rules. Imagine a lawyer instantly getting summaries of all the key court decisions for their case. Huge time saver.
Definitely. And in healthcare, you mentioned doctors getting real-time info. RA could power systems giving evidence-based recommendations, summarizing the latest medical studies or even patient-specific data right at the point of care. Could really help reduce errors, improve diagnoses.
The example was a medical assistant quickly finding research on a rare disease. That kind of thing could genuinely save lives, or at least significantly improve care.
And it goes into education, too. Personalized learning.
Yeah, Ari can create customized learning materials based on how a student learns, what they're interested in, where they need help, makes learning more engaging, more effective, like an AI study buddy pulling up just the right notes or examples when you're stuck. Sounds way better than just reading a textbook chapter.
It really does.
And we're seeing it in finance, too, helping investors make decisions by retrieving real-time news and reports, even spotting potential fraud patterns. Scientific research as well, speeding up discovery by helping researchers keep up with new papers, assisting with patents. So for the learner wanting to stay current, RAG is a pretty powerful tool across many fields.
Wow. Okay, so from finding a company's remote work policy instantly to analyzing clinical trial data for a pharma company, basically anywhere accurate, context-aware information is key.
That's the common thread. Now, it's interesting to look at how RAG itself came about. What were the problems it was designed to solve?
Right. The ebook mentions that before RAG, those purely generative models had issues. Their knowledge was static, right?
Yeah.
Outdated, plus the hallucination problem we talked about. And they often struggled with very specific niche topics where accuracy is everything. And you couldn't easily tell where the info came from. Lack of transparency.
Exactly. Meta AI introducing RAG was a direct answer to those problems. By combining retrieval with generation, they made a hybrid model. It could access current info, understand context better, and be way more useful in professional settings. Plus, crucially, it often cites its sources, giving you that transparency that was missing before.
The source also talks about different flavors of RAG emerging now, like graph RAG using structured knowledge, and multimodal AG for images and video, not just text. Even agentic RAG, where it connects to autonomous agents. Sounds pretty advanced.
It is pushing the boundaries. And the future looks even more interesting. We're talking real-time web retrieval, highly specialized RAGs for specific industries like law or medicine, better ways to explain why the AI gave a certain answer, and just making it all more scalable and efficient.
It's like moving from AI that just talks to AI that can research and then explain what it found. Really powerful. Okay, let's get into the mechanics. What are the actual building blocks of a RAG system?
Okay, fundamentally, there are two main: an information retrieval system, IR, and a large language model, the LLM. The IR system's job is to find and fetch the relevant information from your data, whatever that is. Think about how Google works. It indexes the web, then retrieves pages based on your search.
So things like Elasticsearch or even just the search bar in a company database, those are IR systems.
Exactly. The basic steps are indexing the data so it's searchable, understanding the user's query, searching the index, ranking the results by relevance, and then giving you the top one. And IR systems can be general, like web search, or very specific, like searching academic.
In an IRG, the IR system just grabs the relevant stuff for the LLM to work with.
Precisely. How well the IR part works really dictates how good the final answer will be. Then you have the LLM. As we said, these are the models that are good at generating human-like text. They've learned language patterns from reading huge amounts of text.
That's how they do things like finish sentences, translate, answer questions conversationally.
Correct. Under the hood, there's tokenization, breaking text into pieces, embeddings, turning those pieces into meaningful numerical representation, a transformer architecture to understand context, and then decoding to generate the output text. But as we know, they have limitations, static knowledge, potential errors.
Which is why a RAG combines them.
Yeah.
How does that intricate actually work? Is it like a pipeline?
Yeah, it's a pretty seamless pipeline, essentially. User asks a question. Retrieval phase. The IR system finds the best documents or passages. Generation. The LLM takes the question and those retrieved documents as context. Then it generates an answer based on both. The output blends the LLM's fluency with the IR system's factual grounding.
So the LLM gets like a custom briefing packet just before it answers.
That's a perfect way to put it. A curated cheat sheet. And this combo gives you the better accuracy from the retrieved data, better context understanding, and adaptability, because you can just point the IR system at different data sources for different.
Okay, got the what, the why, the components. Let's really get into the weeds now, step by step. How does RAG do this?
All right, the process usually breaks down into two main stages: retrieval, then generation. Retrieval phase starts with your query. The system analyzes, it figures out keywords, intent, then it searches its index, data documents, database entries, whatever, finds potential matches. Next, it ranks those matches. How relevant is each one? Algorithms like BM25 or semantic search models do this. Finally, it picks the top few results, the top K, they often call it, to pass along.
Okay, so it's like a super fast researcher finding the best few pages on a topic.
Exactly. Then comes the generation phase. Those top K documents are fed to the LLM. They become part of the input, the context. The LLM essentially reads them alongside the original question. Then it generates the answer, drawing heavily on the information from those retrieved documents. The goal is an answer that's fluent, relevant, and factually grounded.
And how does it actually understand the question and the documents well enough to match them up?
That's where things like embeddings come. The query gets processed, tokenized, maybe stemmed. Then it's often turned into a vector embedding like a numerical fingerprint that captures its meaning. The documents in the database have already been processed into embeddings too. So retrieval can involve finding documents whose embedding fingerprints are closest to the query's fingerprint. That's semantic search. Or it can use older methods like BM25, which are more keyword focused, or often a mix of.
And the ranking puts the best matches.
Right. Then those top documents go to the LLM. Using things like attention mechanisms, the LLM figures out which parts of the retrieved text are most relevant to answering the specific. It integrates that context to generate the final output.
The ebook used the example of asking about renewable energy trends. System finds articles on solar, wind, policy, ranks them. LLM reads the top ones and summarizes the latest trends. Okay, that paints a clear picture.
It does. So if you, the learner, wanted to try building a basic RAG system yourself, what tools would you?
Right, getting practical. The ebook lists quite a few. For the retrieval part, finding the info, you've got search engines like Elasticsearch, Python libraries like Whoosh, or the Java library Apache Lucene, which powers things like Elasticsearch. It also mentions BM25 implementation, like the rank BM25 library in Python. So these help you find stuff.
Crucial tools for that indexing and searching step. Then for the LM part, the generation, you've got Hugging Face Transformers, a massive library giving access to models like GPT, BERT, etc. OpenAI's API for GP4. BERT itself is great for understanding text. And for doing those fast similarity searches on embeddings, there's Face from Facebook AI.
And connecting these two sides, retrieval and generation, that's where frameworks come in.
Exactly. Frameworks act like the glue. LangChain is super popular right now, designed specifically for building LLM applications. It has great tools for chaining retrieval and generation, connecting to vector databases like Pinecone or Chroma, where you store embeddings. Haystack is another good open source option, helps build end-to-end search pipelines supporting both keyword and neural.
The ebook even gives a Python code walkthrough using Hugging Face, rank BM25, shows setting up, loading data, retrieval, generation, putting it all together. Sounds like a perfect starting point for the learner to get their hands dirty.
Absolutely. It's a great way to see the core concepts in action, though as the book notes, for like serious commercial applications, you'd usually need more robust setups, proper vector databases, optimized embedding models, maybe paid LLM APIs for scale and performance.
Right. And speaking of scaling up, what else do you need to think about for bigger systems?
Definitely need those vector databases, Pinecone, Chroma, Phase for handling lots of data efficiently. Fine-tuning the LLM on your specific domain data can also make a big difference in relevance. And yeah, frameworks like LangChain or Haystack really shine here, helping you build and manage more complex system pipelines.
The ebook also gets into chunking strategy, how you break up big documents. That sounds important. It mentions things like fixed-size chunks, recursive chunking that respects text structure, using document sections, semantic chunking based on meaning, even using an LLM to decide where to split.
Oh, chunking is critical. How you slice up your documents directly impacts what the retriever finds. Get it wrong, and you might miss key info or get irrelevant stuff. The best strategy really depends on your data and what kind of questions people will ask. And then there's hybrid search. That's combining vector search, the meaning-based similarity, with good old keyword matching like BM25. Gives you the best of both. Semantic understanding and catching those exact keyword hits makes the search more robust.
Okay, so building a production-ready RAG system isn't trivial. Lots of components, lots of choices.
Definitely involves careful. Which brings us back nicely to those real-world use. Understanding the how makes it clearer why it's so effective in areas like healthcare, law, customer support.
Yeah, empowering doctors, lawyers, support agents, making information more accessible and reliable. It really clicks now.
But like any tech, it's not perfect, right? RAG has its own challenges and limitations. What are some of the big ones?
Well, data quality is huge, according to the ebook. If your source data is messy, biased, or just plain wrong, the RAG output will reflect that, garbage in, garbage out, basically. And keeping the data fresh is another hurdle, especially for fast-moving topics.
Absolutely. You need solid processes for cleaning data, checking relevance, maybe mitigating bias, and definitely regular updates. Then there's ambiguity. User questions be vague. Understanding the real intent, the context, can be tricky for the AI. Plus, LLMs have those context window limits. They can only pay attention to so much information at once.
The book mentioned techniques like query expansion to clarify vague questions and summarizing context to fit it into the LLM's will.
Yeah, important workarounds. And then there are the practical. Compute resource. Running big models, searching huge data sets, take horsepower, costs money. Scalability can be a challenge too, handling lots of users without slowing down. Latency, the delay in getting an answer, is key for experience.
So optimizing resources, designing scalable systems, using caching, all that becomes crucial.
Definitely. And research is constantly happening to improve retrieval, make models better, integrate with other tech to address these things.
Makes sense. Solving these challenges is key to making RAG truly robust. Okay, so if you're deploying one of these systems, what are the best practices for keeping it running smoothly long-term?
Good planning upfront is think about scalability, modularity, making it easy to swap components later, and fault tolerant. How does it handle errors? Choosing the right infrastructure cloud, on-prem managing resources, and nailing down security and compliance from day one. Very important.
The ebook stresses continuous monitoring too, watching performance in real time, setting up alerts, optimizing things like indexes and models regularly.
That's key. It's not set it and forget it. Data management is also on. How do you ingest new data? How do you update existing info? Handle data growth, maybe archival, and regular maintenance systems, applying patches, upgrading components carefully, usually with testing. Standard IT practice, but critical.
And finally, user feedback seems vital. Actually listening to users, seeing what works and what doesn't, and using that to improve the system iteratively.
Couldn't agree more. That feedback loop is gold. It tells you where the system shines and where it needs work. Continuous improvement.
Okay, we've covered a ton. From what RA is, why it matters, how it works, the tools, the challenges, best practices. It's clearly a really dynamic field. So, looking ahead, what are the most exciting future trends for RA?
Oh, the future looks really active. Language models are just getting better, bigger, more capable, even multimodal, understanding images, audio alongside text. We'll see more fine-tuning, creating specialized models for specific industries that are even more accurate for those tasks.
And retrieval getting smarter too. Better search algorithms, using knowledge graphs for deeper understanding.
Exactly. Things like advanced vector search, dynamic indexing, integrating structured knowledge from graphs, it all leads to more relevant results. There's also a big push for responsible AI tackling bias, making systems fairer, more transparent, more explainable, so we understand why they give certain answers, and integration with other tech, like federated learning for privacy-preserving training or edge computing to run parts of them closer to the user for speed.
So, smarter, more versatile, more ethical, more integrated. Sounds like the ebook also flags some specific areas for listeners like the learner to explore more. Graph RAG versus fine-tune, multimodal RAG, cloud services, open source. Also touches on evaluation metrics, text-to-SQL RAG, agentic RAG. Lots to dig into.
Yeah, those are all super interesting threads. Graph RAG leveraging structured data is powerful. Understanding how RAG compares to just fine-tuning an LLM is important context. Multimodal opens up huge possibilities. And knowing the tools, cloud options, that makes it accessible. Agentic RAG is really pushing the envelope on AI autonomy.
And for that hands-on feel, the ebook has that LangChain guide to build a simple RAG system. Great practical starting point.
Definitely. Lets you see the people.
Well, this has been a fantastic deep dive into retrieval-augmented generation. We looked at its core idea, that hybrid approach, why it's so important for accuracy and context in AI, the huge range of applications, the mechanics, the tools, the challenges, and the really exciting future trends.
And hopefully for the learner and everyone listening, we've managed to make this complex topic feel, well, understandable, delivered some of those aha moments without the overwhelm.
So here's a thought to leave you with. How might RAG change your relationship with information? Are we moving towards a future of truly personalized knowledge assistance? AI that doesn't just answer, but researches and synthesizes information just for you. It's a pretty compelling idea to think about.
It really is. Definitely check out the resources in the ebook if you want to go deeper. Think about how RAG could apply in your own.
Thanks so much for joining us on this deep dive. Hope you found it valuable. Until next time.